To wrap up this lecture, let's compare and contrast the types of inheritance we've seen in this lecture. So the first is interface inheritance. Love it. It's wonderful. It's just a great idea. It tells you what you can expect from your subclasses. So the superclass or the interface says all lists must do these things and allows you to generalize your code in just a powerful, simple way. So if we look at word utils, for example, this longest method, it works on any list. And not just any list, but any list that will ever be written. So if in 1,000 years someone digs up my code, like my skeleton laying somewhere holding a USB drive, and they find this, and they're like, yes, this is good. And they're like, well, we don't have a list implementation except this weird 1Q list. Well, as long as it obeys the list61b interface, I don't know how it would, it'll still work. That's nice. There's also this other kind of implementation inheritance, which tells you how the subclasses should behave. Okay? In this case, the boss is telling its subordinates exactly how to do their job. So this is nice because the boss can provide a general working print method, for example, that anybody else can use. So if you make a new list called QList and you're not quite sure how to print, you at least have that laying around. It may not be the most efficient way, but it's there. So it gives you an extra level of control. You can decide to override it, not override it, so that can be nice. Now in both cases, I want to point out a common pitfall that you may fall prey to. Anytime you use inheritance, either kind, you should be specifying an is-a relationship and not a has-a relationship. Okay, what do I mean by that? Well, an example of an is-a relationship is this. A dog is an animal, right? I mean, every dog is an animal. And likewise, every S list is a list61b, right? That's great. We specify those things. By contrast, if you read it as has-a, that's no good. You don't want to use inheritance in that case. So for example, if I make a class called cat and it implements claw, it is true that cats have claws, but a cat is not a claw. Now you might say, that seems weird. Why would I ever even try to do that? But here I think is a better example where you can maybe see why you might get tempted into going to the dark side. So if I say set implements slist, basically what I'm trying to do is implement a set using an slist. So what's a set? A set is a collection of objects that can have no duplicates. So for example, if I call add first potato, add first potato, add first potato, there would be only one potato in the set. So you can imagine trying to override the slist methods to capture that behavior, whatever it may be. And so in effect, we'd be contorting an slist into a set, but it won't work the way you want. It's going to end up being much more complicated. Okay? So that temptation to use interface or implementation inheritance to capture has-a relationships, please avoid it. Okay? So that aside, I actually want to talk just for a moment more about some of the reasons I'm a little skeptical of implementation inheritance, why it can cause you trouble. So one issue that sometimes applies is it can make it hard to keep track of where something was actually implemented. So imagine you have a deep stack of 6 or 7 implementations. So, I have animal, and then I have carnivore, and then mammal and dog or whatever. It can be hard to potentially keep track of where things got overridden, where they got defined, and so forth. Though a good IDE makes that pretty much okay. But it can mean some extra complexity. 2, well, sometimes you can get strange conflicts. So imagine you have service and service or helper, we'll say. So you have a helper interface and an animal interface, and then you want to make a service dog class that implements something implements both of those superclasses, those interfaces. In that case, if there's a conflict between these, maybe they both have the same default method, there's some complicated rules about resolving those. Not such a super big deal in Java usually, but it's one thing that's a little ugly about implementation inheritance in general. Another one, and this is where it's starting to get worse, is it encourages overly complex code. Because when you have a hammer, right, everything looks like a nail. So whenever you know about inheritance, especially when you're new to it, you're going to want to go nuts with it possibly. And the biggest mistake people make is this has-a versus is-a problem. I actually had a similar thing at my first internship a long time ago where I just learned about Yak, I think it was, or Lex, or one of those compiler writing tools. You've never used them probably. But I had a task and I managed to find a way to use, I forget, it was for generating random parameters for some program. And it's so funny, I think back at this piece of code and how I managed to use the tool I had just learned about in an overly Byzantine way to solve a problem. Inheritance, especially implementation inheritance, and only implementation inheritance, I'd say, leads to this just gross behavior. But perhaps worst of all, is this fact, the fact that it breaks encapsulation. So I'm not going to tell you exactly what that is. We'll cover it in a couple lectures. So just for now, understand there's some philosophical exceptions I have to implementation inheritance. Now, I'm not saying it's bad. I mean, it's a wonderful tool. There are cases where it saves you tremendous amounts of time and it can be very lovely. But unlike interface inheritance, which for me is a clear win, implementation inheritance could be a little bit shaky. All right, that's it for this lecture. So I'll see you in the next set of videos. See you then.